regarding the orientation of this hall. So we are currently located at 10M floor. So washrooms is located at 10th floor. It's just downstairs from here. Also, the male surau is located on the same floor, and female surau, I think we don't have any elephant here, so it's okay. Um, Apart from that, this training session is brought to you by Global Technical Solution (GTS) in collaboration with UTM, Ampesimon, and also Mahapower Sdn Bhd. So GTS is registered with Suruhanjaya Tenaga up to 500 kV. We established in 2016, and we are specialized in providing electrical services covering LV to HV. So basically, it is includes the protection relay calibration. The HV is for the transformer diagnostic test, motor diagnostic test, generator, and also switchyard equipment diagnostic test. Okay, so without further ado, before that, I'll just introduce. We will have three speakers, which are the protection specialists from GTS Malaysia. We will have Mr. Elumalai Pasani Sami. Elumalai, please say hi.
Hi.
And then the second one, we have Mr. Rajarajan Atitan from GTS India. And the third one, our protection specialist is Mr. Uttam Mishra. He's also from Melbourne. So without further ado, I would like to call upon Mr. Rajarajan Atitan to proceed. Thank you.
You can sit anywhere. Is it possible to hold this like this? I am going. After 10 to 15 minutes, you can off. Aku belum register je ni. Tak payah. Tak payah.
Yeah, very good morning. Let the mic on. Okay. So, myself Rajarajan, I'm from India. I'm working with this protection field for past 18 years. This I'm going to give a small or brief introduction about the protection foil, particularly the transformer protection, particularly the transformer differential. Once the transform, I'm going to cover basically the theoretical part, the transformer differential and what are the challenges encountered during, what are the challenges that you are facing to adopt the transformer prevention schemes. Then later on, Mr. Elumalai will cover the technical part, the calculation part and the testing part. Before moving to it, just look into the transformer protection. Actually, this is the transformer definition of the transformer as per the IEC as well as the IEEE standards, which defines, as everyone knows, it is a static apparatus which is having two or more windings, which is going to transform the voltage and the frequency. Sorry, the frequency will remain the same. It will transform the voltage alone. This is the definition of the transformer, and we'll look into the transformer components. These are the major transformer components. There's a bushing that's used to connect the cables, the HV and LV connectors, and the winding. In some cases, it will be a two-winding transformer. In few, it will be a three-winding transformers. That depends. Then we have cores where the windings are insulated. Sorry, where the windings are mounted. Then the radiators, the whole tank, and the tap changer is used to change the taps on the windings and the insulations. So then comes, before going to the protection, just we'll look into the types of faults that is we might encounter in a transformer. The first and foremost, the transformer fault caused by a long time overheating, causing an aging of insulation, or so many factors. So the overheating can be caused not only because of aging, but also due to the short circuit, either in zone or the out zone, both the cases. And also the transformer may overload for a prolonged time, then the overheating will comes to the picture. Also, if you have a oil seepage, and some transformers, the oil seepage will also be there. So the oil seepage maybe leads to reduction in the oil level. So oil is basically used as a coolant of a transformer. If the oil level is goes down, then also it leads to increase in temperature of the windings, or the enough cooling medium is not there, then also it leads to the overheating of windings and cores. So it leads to the failure of a transformer. Then the short circuit current. The short circuit current it leads to mechanical stress because the large amount of current is drawn when the short circuit happens. So either it would be in zone or it would be out zone fault. So it will give a huge amount of burden the transformer. So it will give a mechanical stress in the windings. So you could see the transformer windings during overhauling. You can see these are the fixed runners in a winding. Let's say if it is, this is winding. No, this is one half phase alone. These are all the runners. So this will be your this is your winding. So the winding will be, you can see such kind of such kind of the winding might come down. It will lose its original position due to the mechanical stress, due to short circuit, or due to the prolonged due to the short circuit, as well as due to the overfluxing. If suppose large overfluxing is there, then the magnetic inrush will be huge, so it will impact on the winding the winding installed in the transformers. So then another one is the climatic condition, maybe the lightning or the climatic conditions or the low voltage may leads to this transformer failures. And third are bad oil quality. So this oil quality is more important in terms of transformer. The once the aging, due to the aging, the oil will absorb the moisture. Once it absorbs the moisture, it will lose its dielectric strength. Once the dielectric strength of the oil is weakened, it will also lead to the decrease in insulation level. So usually transformer, let's say this is a core. So usually the transformer construction will be like that. The core will be at the center. The inner winding will always be the low voltage winding. The outer one will be the high voltage winding. Why HV is in the outer side? Because it is easier to get the tappings. We need to get the tap changes. So the tap changes can be installed very easily. And also, if one turn, if we change in the HV, we will have a smooth replica in the LV. So we will always use the on-load tap changer or the off-load tap changers in the HV side, not on the LV side. Why? Because the HV is easy to access. If we turn a one winding or one turn, it will have a smooth replica, and LV fine tuning, small fine tuning can be done using HV. One turn can lead to a fine tuning of the LV voltage also. This is the one thing. And also the HV side, the current will be less when compared to LV side. So the arcing or the other phenomena will be avoided when the OLTC is installed in the HV side. Then the windings are like that. So it is filled with oil. Coming back to this one, is the oil. Sorry, sir. Okay. So this oil will serve as two purposes. One as a cooling medium for the transformer. Why? Because the core and the winding will heat up once you start using the charging the transformers. So we need to maintain the temperature. So the transformer oil will act as a cooling medium in one case. In another case, it will also act as a insulation. It will be an insulation between the tank and the winding. So in both ways, the oil will be used. So another case, if the oil absorbs moisture, what will happen? So by aging, by once the time goes, the transformer oil will start absorbing moisture. Once it absorbs moisture, its dielectric strength weakens. Once the dielectric strength weakens, so the insulation level between the transformer, between the cores will also go down. So then ultimately leads to transformer failure. So this is another case. Then insufficient cooling ducts in the winding. So this is not applicable in all the transformer. This depends on the where the transformer is installed. Let's say if it is in a mining industry or if it is in a paper industries, so the cooling ducts will be settled with lots of dust or the external foreign particles. So ultimately, what it will happen? It will block the radiation of the heat or the exchange of the heat. So it ultimately it leads to overheating of the transformers. So that it leads to failure. So once if we clean the ducts properly and frequently, this problem can be overcome. This insufficient cooling. Then the partial discharge, the latest one, it is the partial discharge in the insulations of the transformers. That's also another case. And this is the and this is the one which faults. If once the fault happens, the transformer failed. So this is the general analysis. What could be the affections? So let's say we are seeing the components of the transformers. If a fault happened, if the transformer failed, which is likely to be failed, is the winding suppose. So once the transformer fails, the most common component will get affected is the winding, the first one. The second one is the 20%, that is the that's miscellaneous or the unknown reasons. Then the 15% is the OLTC, since it is having a moving part. The failure rate of the OLTC is more. And another one is the bushing and the insulation. These are all the this is the common failure rates, the transformer components. And why it is failing? The reasons that we have shown before. Then what are all the types of fault that could lead to this failure? So one is winding short circuit. So the winding short circuit that is very rare event that may not be available or that may not happen in the practical cases. That's very rare because the windings are separated completely from one limb to another limb. So the winding short circuit is very rare event, but other things are likely to happen. The interturn faults or the short circuit current, that is more common, and the air fault as well as the tap changer failures. So in case of the interturn faults, so the interturn fault is nothing but in a winding itself. If the winding will be insulated with the paper, the insulating paper. So between the insulation, between the windings, if the paper absorbs moisture, the oil absorbs the moisture, then it will ultimately transmit to the paper. So if the paper absorbs the moisture, it will leads to the small leakage current between the windings. So if the small leakage current occurs, that leads to the interturn fault between the winding. That is the one case. Another one case, the short circuit. That is short circuit usually the out zone fault, not the in zone fault. This is another one is out zone fault. It could be face to face fault or face to ground fault or another what's possible three phase fault. Three phase was very rare. Then earth fault. earth fault, it could be both ways, out zone fault as well as in zone fault, outside the transformers and also the inside the transformer. So inside the transformer, what could be the probable option, the probable way it could be the earth fault?